Good morning! I'm about to make my next batch of videos for you. Ultimately, we're going to do lesson 5.5, 5.7, and 5.8, which is more trig stuff, graphing, inverse functions, and another word problem. We will then go into chapter 7, and I am only doing two sections of chapter 7. We are doing law of sines, law of cosines, and areas of non-right triangles. We are not doing polars. So the first thing we're going to do is we're going to learn how to graph y equals sine x on 0 to 2 pi. Y 0 to 2 pi because that is the full cycle, one complete cycle, keeping in mind that pi is 180, so this is technically 360. So we have our magic circle that is in your bag of tricks that I keep reminding people that you need to print out a copy of the bag of tricks, which is in course docs, and have it in your paper pile. In a perfect semester, that would have been memorized material. So everything in the bag of tricks is stuff that you will be required to know if you are going into any upper level math of any level of calculus. It will need to be memorized. That's why it was memorized in this course. So finally, remember to print the bag of tricks and use it consistently. So in this bag of tricks, I have this titled as magic circle. So this is 0 degrees, 90 degrees, 180, 270, and back to 360. At each of these pieces, which are quadrantal angles, recall those are angles that are multiples of 90, we have ordered pairs. So here it is 1, 0, here is 0, 1, negative 1, 0, 0, negative 1. These are the domain and range for sine and cosine only. Those are the only ones we are graphing. However, we are going to move them up and down, left, right, make them shorter, make them taller. So this domain is negative infinity to infinity, and the range is bracket negative 1 to 1, which means that we can never be bigger than 1 and less than negative 1. So when we go around in the ordered pairs, recall that ordered pairs are in the order of cosine sine. It's alphabetical. So for example, at this 0 degrees piece, cosine is 1, sine is 0. At 90, cosine is 0, sine is 1. At 180, cosine is negative 1, sine is 0. And at 270, cosine is 0 and sine is negative 1. Now we need to do that because we need to make a t-bar. So this is the one and only time we're going to make a t-bar for sine. So when we do sine, we have to be in the radians, not degrees. So this is 0 degrees, pi over 2 is 90, pi is 180, 3 pi over 2 is 270, and 360 is 2 pi. Once again, this is the only time we're making the t-chart. We're going to be doing them starting on the graph and then working backwards once we start examples. So we talked about our pieces over here. So at 0 degrees, we are doing sine, so sine is the second piece, hence it is 0. At pi over 2, sine second piece is 1. At pi, second piece is 0. At 3 pi over 2, second piece is negative 1. And at 2 pi, second piece is 0. Sine values for one complete cycle. So then we have to go out here to a graph. And on the y-axis, we have 1 and 2 and negative 1 and negative 2. What we're going to do here is we're going to label our pieces out. So I want us to always have it be symmetric. It has to be symmetric. So what I do is I make sure that between each piece is 3 spaces. So I would count 3 spaces on the graph. Those equate to boxes. Call the first one pi over 2. 3 spaces counted again, call it pi. 3 spaces again, call it 3 pi over 2. And 3 spaces again, call it 2 pi. So then we're going to plot these as if they are ordered pairs. So at 0 we have 0, pi over 2 is 1, pi is 0, 3 pi over 2 is negative 1, and 2 pi is 0. We connect all those dots. This is called the period. That's what this red stuff here says. Period is one full cycle. One full cycle. I call sine 2 humps. So sine will always be 2 humps. So you will know that when you are done and see one complete cycle of sine, because that is what we will do all the rest of the semester, is one complete cycle. Sine is 2 humps. If it is positive, it will be up hump and then down hump. If it is negative, it will go down first and then up. The amplitude, without us doing any sort of shifting, is the distance from the x-axis to the max or the x-axis to the min. This is a graph of y equals sine x. Recall you need to put x and y as your labels. We now have to do the graph of y equals cosine to see their difference in their shapes and their numbers and so on. So we're still going to do it from 0 to 2 pi, so we have a full cycle. We're still going to do our t-chart one and only time we are making the t-chart for cosine. We have 0, pi over 2, pi, 3 pi over 2, and 2 pi, just like we did for sine. But when we go to the ordered pairs over here, we're going to take the first piece of each ordered pair because that's the cosine. Remember, it's cosine, sine, alphabetical. So at 0 degrees, cosine is 1, so we put 1 in the picture. At pi over 2, cosine is 0, so this is 0. At pi, cosine is -1. At 3 pi over 2, cosine is 0. And at 2 pi, we are back at 1. So this t-chart is going to draw over here. So once again, we have 1, 2, and -1, -2 on the y-axis. We label our axes x and y. And then we have 3 space counts again. So we have 3 space counts to pi over 2, 3 space counts to pi, 3 space counts to 3 pi over 2, and 3 space counts to 2 pi. We then are going to plot the ordered pairs. So we have 0, 1, then this is pi over 2, 0, then we're at -1, 3 pi over 2 goes back to 0, and 2 pi is at 1. We connect the dots, and we have a completely different shape than we did with sine. Our amplitude is still the x-axis to the max or the min, because we have not shifted it at all. Our period is still one full cycle, going from 0 to 2 pi. When we are dealing with cosine, if it is positive, which is the one we drew here, it looks like a valley, swings down and looks like a valley. If it is negative, it would swing up and looks like a mountain. So cosine is either a valley if it is positive or a mountain if it is negative. Recall, sine is 2 humps, up hump, or down hump, up hump. We now have to come up with the characteristics that are similar and different between a sine bx, notice this time we have a and b, and y equals a cosine bx. So the characteristic that they have that's the same is the amplitude. The amplitude is called the absolute value of a. And a is the number that sits in front of the trig word. So here's your a in a sine bx, and here's your a in a cosine bx. So the amplitude is absolute value. So it will always be positive. It is the distance, it's how far you walk between the max and the min. So when we look at this, we have to come over here and see what was the gig up here in sine. Well, in my original sine, there's nothing there, so it's understood to be a 1. So the absolute value of 1 means that my amplitude is how tall it is and how low it is, and that's where your 1 comes in for amplitude. Same thing here for cosine. This is an understood 1, so the amplitude was 1 for my height and 1 for my depth, if you will. Second thing we pull off of this is called the period. Period is always in the expression of 2 pi over b. 2 pi, because that is 360, over b. This b comes from the number that's in front of x. So there we have our number in front of x. So if we recall, when we were up in here, back to this, there's no number in front of x in the sign. So it's understood to be 1, which means we would take 2 pi divided by 1, which gets 2 pi, which is how we see 2 humps out to 2 pi. If we had done it on the cosine piece of our original example, there is no number there, so it's an understood 1. So 2 pi over 1 is 2 pi. So if we were to do this out, we go the full cycle. In this case, it was the valley because it's positive, but it ends at 2 pi. Period, 1 complete cycle. Third piece component is our x-intercepts. Now recall, x-intercepts are the pieces where they touch the x-axis. So sine has 3 x-intercepts. The first one, the middle one, and the end one. So sine will always have 3 x-intercepts. Cosine only has 2. It's after it has started at its max or min, it hits an x-intercept, spins down or up depending if it's positive or negative, and hits the x-intercept again. So cosine only has 2. Look at the pictures. Sine will always start at 0, and cosine will always start up or down depending on if the problem is positive or negative. The next piece to graphing these, we're going to graph the points with x and y, so we're going to move down the line. Recall, no more t-charts, and you should not be using your graphing calculator. And last, we'll extend it left or right with plus or minus pi pieces, which we'll see in a bit, so sometimes there's a combination of them together. We're going to move up or down with plus or minus numbers. So when we move left, right, we're going to be moving across pi pieces, which is significantly more difficult than moving up and down, which are the regular numbers we're more familiar with. So the first example we're going to do is called y equals 2 sine half x. And we're going to do one complete cycle of it. One complete cycle. So amplitude is the absolute value of 2. It's the number in front of sine, so we get 2. Which means we're going to have a max of 2 and a min of negative 2. My period is 2 pi over 1/2. So 2 divided by 1/2 is not 1, it is 4. So my period is 4 pi. This is normal because the 2 is positive. So this means the up hump will be first and the down hump will be second. Now notice we don't have a t-chart to go over and make ordered pairs. So we have to create our own labels for the x-axis. Now up here I was pretty stringent about 3 space counts. Because if we do that, we have 3, 6, 9, 12. Very consistent. So my one complete cycle here is going to be out at 12 space counts. 12 space counts. So you would literally count 12 spaces across your graphing paper. And at that 12th space count, you're going to call it the period, which in this case is 4 pi. So 12 space counts, nice even symmetry, and you'll call that 4 pi. That will be where our final piece of sine lands. Keep in mind, we're not shortening them, lengthening them, we're seeing one complete cycle. If it's sine, it is 2 humps. Now we are tasked with labeling these, and I call it half back. It's a fancy, fun way of calling midpoint. So if at 12 space counts we have 4 pi, halfway space counts is at the 6th space count, and halfway between 0 and 4 pi is 2 pi. We then need to label this one, so this would be 3 space counts, everything is symmetric, and halfway between 0 and 2 pi is pi. Then we have to do this piece here. If I'm at 6 space counts and 12 space counts, halfway space count is 9 space count. If you're on graph paper, symmetry is amazing. And halfway between 2 pi and 4 pi is 3 pi. So once these are labeled, the picture becomes actually quite simple. Sine starts where? It starts at 0. So we're going to start at 0. According to my amplitude, I'm 2. So at my next space count, I don't care what its name is. Once it's in, it's in. I'm going to be at 2. My next space count, I have to go to 0. There is my up hump. My next space count, I have to go to negative 2 because that is my min. And then I have to go back to 0. So there is the down hump. So up hump, down hump, full label. Next question. Example number 2. It says y equals negative 3 cosine 2x. We're going to do one complete cycle. So amplitude, absolute value of negative 3, which is 3. Keep in mind it's always a positive amplitude. It's a height. It is a distance. And period is 2 pi over 2, which is pi. So this one, I say, is going to be reverse or flip because of the negative. So when we have negative cosine, that is going to produce the mountain. So we have to come over here, we have to label our axes up 3 and then down to negative 3. That will take care of the amplitude piece. So I have 1, 2, 3, negative 1, negative 2, negative 3. But more tasking is labeling the axes. So we're going to go out our 12 space counts, which is what this orange thing over here says, must be symmetric with 12 space counts. So we're going to count out 12 spaces, and at the 12th space count we're going to write pi. So we're going to put pi here, and that is our 12th space count. Now we have to half back. We have to name them. So the halfway between 0 and 12 space counts is 6 space counts, and at 6 space counts we are going to call it pi over 2. I call this the money one. Think of pi as $1. Well, halfway between 0 and $1 is 50 cents, which is pi over 2. Now I have to go here, which is the 3 space counts, and halfway between 0 and 50 cents is 25 cents, which is pi over 4, 1/4. And then between 6 space count and 12 space count is 9 space count, and halfway between 50 cents and $1 is 75 cents, hence 3 pi over 4. Once again, after these are in, it's a piece of cake. So you come back over here, and we are going to plot cosine. Keep in mind the expressions for cosine are, do I start high or do I start low? And because it's a -3, I'm starting low because I'm going to create the mountain. Start low, go high. So I'm going to start at -3 at the 0 space count, for lack of a better expression. At the next space count, once again, I don't care what its name is, it's already there. I'm going to be at 0, creating this mountain appearance. At the next space count, I have to hit my max, which is at 3. Then I have to start coming on my way down. So I'm going to come down here at 0, and then I come back down here at -3. One complete cycle, labeled, and mountain, because it was negative. What I'm going to do now is I have to turn the paper over because there's more examples of this on the back. This is one of those things where the repetitiveness is as important as the problems themselves. So in class and also on these notes, I did a lot of examples. If we had done this in class, I would have only done one lesson on this day. We would have gone over the homework from the prior day, this would have been quiz day, and we would have done one lesson because it is so important to do repetitiveness of these. So we have 2 more examples of this 5.5 before we head into our inverse stuff. So let me get this taped up here. Hopefully this is better than what I did last time with the shakiness of trying to hold it. Everything's an experiment for me. Okay, so example number 3. We have a bunch of stuff going on here. So I want us to focus on the green part first. So example number 3. Y equals sine, parentheses, 2x minus pi over 2. We're not going to deal with this purple piece yet. We're going to ignore that for a minute. In class, I would not even have that there yet. We would be adding it at the end. So we are going to do that y equals sine, parentheses, 2x minus pi over 2. So here we go. Amplitude, absolute value of the number in front. Absolute value of 1 is 1. Period. 2 pi over 2, because that is the number in front of x. This piece does not affect amplitude or period. So 2 pi over 2 is pi. So when we go to our graph, this will be the period at the 12 space counts. That will always be the way that we do these. So period at the 12 space counts. But this time we're introducing phase shift. Phase shift is the horizontal shift of old. So the horizontal shifts of old were always when you're inside parentheses, you keep or change. And the answer to that was change. So if this is negative, we have to go opposite, which means we are going to go right. We're going to shift to the right. And we take this pi over 2. So we have right, pi over 2. But the kicker is we have to divide by the number in front of x.